Hello, folks. It's George Leoniak, and welcome to New Geometry. Today, I'm excited to celebrate my 100th video, and it's going to be a special video because we're going to return to the flower of life. We're going to construct all the Platonic solids and a few other forms with no lines in the circle pattern until we draw the forms themselves. So there's a 66 circle layout of the flower of life with some additional circles, but no lines are going to be used in the setup of that at all until we get to the drawing of the forms themselves. So it's a very unique drawing and very, very cool, and I'm excited to share it with you today. We're going to do this in a different way. I have a presentation set up, but first we're going to go to the iPad and do the drawing and show you the drawing as it progresses. And I think that will illustrate the cool pattern as it unfolds. So let me switch over to the iPad and then we'll begin. Okay, so we're all good to go. So no lines are going to be used to construct the pattern. We're just going to do the seed of life pattern into the flower of life. And let's just do that. So we're going to do our first 6 circles, 7 circles around 1. And we're going to go all the way to 19 circles, constructing the flower of life pattern. Now, this pattern will go on forever if we don't draw some lines in here, maybe to switch it into 4-direction view or even do pentagonal geometry. We'd have to add some lines in here, or else all we can do with a compass of the same size radius, which we are going to change our radius at some point here in just a moment, but all we'd be able to do is just continue to do circles and circles and circles like this. No way to break the pattern at all. So the flower of life, though, is the key to setting up the way to add a circle that is centered off the 1.5 distance. So if this was a 1-inch circle in the middle, we're at 1.5, 1.5 circle, and we're going to make a vesica here of these 2 circles. And that vesica is going to be the key that is going to open up the flower of life to a whole other addition of adding root 5 circle. So that circle right there is the square root of 5. We're only going to need 1 circle like that, and that is the key circle, because all that's going to do is, not all, it's going to do the whole thing. It's going to allow us to introduce the phi ratio into this. Now, part of my interest in developing this diagram was, how do I get the phi ratio into this pattern if I'm just working with circles? Because that's always been about divine proportion, divine cut. You know, you take a line, you cut another line right at the divine point. Well, how am I going to do this in here without doing any lines? So this allows us to add a square root of 2 circles. So this is going to open up opportunity to start creating the divine proportion within this. We're going to have to add 6 of these. I just want to show you where that's anchored off of. 1 circle here, and it's interacting with the intersection point of the unit 1 circle, this upper one, and that root 5 circle. And we wouldn't be able to draw that root 2 circle at all in the diagram until we get the intersection of the root 5 circle with that 1-inch circle. And we'd have to do 6 of these. Now, there are 66 circles that we're going to add to this. And the beauty of adding these root 2 circles in the diagram is that right now, this 6-pointed star shape in the middle of the flower of life, that is our first golden circle. We're going to clean this up. We don't need the big circles. They just make it complicate some of the intersections in here. So we've taken those out. That creates the first golden ratio circle right within that, where the root 2 circles overlap within. And now we are going to be able to fill up our whole golden ratio flower of life here, all with golden ratio circles. That circle that we're putting in here is 0.618 in diameter to the 1-inch diameter of our central circle. And the root 2 circles intersect at this point right here. So we can add in all these golden ratio circles, 6 more around the 1. So the golden ratio has been introduced. And now we can actually add the 0.382 circle, which is in golden proportion to the medium-sized circle around it. That one's going to nestle right in the middle of those 6 golden ratio circles. And now we're going to be able to do all those outer 6 circles again. So, and then we're going to hop up to the outer ring. So all 19 circles are going to be full of the phi ratio with no need to do any lines in the diagram. As you can see, all we're doing is just adding more circles, and they're all butting up and nestling in with one another. And the root 5 circle that I got from the overlapping of the 3-inch diameter circles, 2 of those, was really the only one circle that made the huge impact and difference in there, allowing square root of 2 to enter the diagram. Until then, I had no way of doing anything different than just putting the same size circles on and on and on. And that's why root 5 is so essential to the phi ratio and instilling this diagram with a lot of life and the geometric forms that are going to be associated. So there is our layout. Now we're going to add in just a second here our first form, and now we're going to introduce the lines as we go around. We're going to make a hexagon because this form really creates hexagons very well. Now in most cases, this hexagon that I just did would be considered the outline of a cube, but in this new geometry, the new NEW geometry and KNEW geometry, this hexagon is going to take on the outer shape of a few different forms, but the first one we're going to start out with is the rhombic trichontahedron. And I'm drawing that in, just the outline and the edges. And it has a hexagon in the middle that is centered within the larger hexagon. Those 2 hexagons, the larger one and the smaller one, they're in phi proportion to one another. So this whole image of this is not halfway point like Metatron's cube shows, one cube within inside a cube. This is now the geometry of this form from this perspective, the rhombic trichontahedron, which has golden rhombic faces. And you can see it looks like the outline of a cube there, right? And the outer hexagon, when we draw it 2-dimensionally, it's the shape of a hexagon. So golden ratio, the kind of master form of the phi ratio, the forms related to phi ratio, because within this one, we have the true drawing of the icosahedron, which is not a straight line like Metatron's cube drawing of the icosahedron portrays, but has this little bend to it here. So that's going to be the face of, that's the face, one triangular face in the middle, and 3 other faces around it that are sloping away. We're adding these additional lines. Now notice they're all within the diamond faces of the trichontahedron. And now we're going to add in our dodecahedron. Let me just zoom in a little bit so you can maybe see the red lines that are coming in here easily. And they are going to cross the blue lines directly at the midpoint of both. And they're making a compound now with one another inside the rhombic trichontahedron. And there is our dodecahedron. And I've excluded the back lines and these side lines here that connect to the back line, just to give it the appearance of more of a solid shape, integrating within the trichontahedron. So all you really see are the crisscrossing edges of the lines, similar to this form I have in hand here, like that. So this is all the lines on this are the crossing of the icosahedron and the dodecahedron compound into the rhombic triconahedron. So when we draw it this way, it doesn't turn out to be a cube at all. It turns out to be the form that contains 5 cubes and 5 octahedra and the icosahedron and a lot of things, stellated forms. That's why this is such a foundational form and, in my mind, really the evolution of sacred geometry and how we relate to it and how we depict it and how we work with these multiples of 5 within these forms. All right, so let's take away the triconahedron lines. So we can just see the compound of the icosahedron and dodecahedron. And now I'm going to slowly start working through the backwards to the smaller forms inside these. So there's our dodecahedron in the compound with the icosahedron, and I've added the back line here. So now you can see more fully the two crisscrossing one another without connecting the dots between the vertices, 12 vertices of the icosahedron to the 20 of the dodecahedron, are what create those vertices of the tricontahedron diamond-shaped face form I was just showing you. And that one has 30 faces. So we're going to take away the icosahedron because there's a few ways that this icosahedron can be shown with the dodecahedron, and I'll show those in the presentation. You can kind of have that dodecahedron inside that icosahedron. In this case, we've done the compound version. But all the rest of the action is going to happen in the dodecahedron and the cube, that 5 cubes that are contained within it. But something radically different is going to happen with the cube here inside the dodecahedron. It's going to make it very different than how it's normally portrayed in Metatron's cube version, or just a hexagon type of cube where it's oriented straight. Each of these vertices are associated to one of the 5 cubes. And when I put the hexagonal version of the cube in here, I'm only going to do this version of it. That hexagon of our outer cube is going to basically run its edges along the face of the pentagon. So one cube will have an edge, and if I did all 5 of the edges of the cube on here, you would get these pentagram stars on the face of the dodecahedron, just like this. So this is how the 5 cubes are contained in there. It's not as easy to draw the form without this orientation, but it means the cubes have to adjust to the dodecahedron in this format here with the layout like this. So let's now take away the dodecahedron, slowly taking away the line. So we just start to work with what's in the cube. So of course the cube, here it is in its angled shape variety, has a tetrahedron in it that is facing down and another tetrahedron that is facing up. And before we remove these lines, essentially, if you just draw a crisscross on each cube face like this, those are square root of 2, but each of those square root of 2 or a multiple of square root of 2, each of those are going to be tetrahedron edges of the 2 tetrahedra that are in here. So now I have to construct the rest of that for you, but you can see that the points line up on our diagram. So here is the blue tetrahedron that's pointing towards you. I just have to eliminate these back lines to give it the shape as if it were one on top of the other. And of course, this is a vertex view of the star tetrahedron, stella octangula, and octaangula. And it is looking at you like slightly like this right now. Remember, there's 5 of these, and 2 of them share this central vertex here. So that's the view. It's not a side view. It's a vertex to vertex view, meaning my thumb that's behind here is directly in front of the other one that you see here, in front of my pointer finger there to the back. So inside this, we have the octahedron. I dropped one little circle in there as a guide to guide this. You don't really need it because this edge of our octahedron is going to run through that phi ratio point till it meets this golden ratio circle. But for the ease of the drawing, I just put this circle in there. And now we just work our way around to show the rest. I did that a bit fast, so let me just transition back. You see the octahedron is already in there. We have a face of it because really this star tetrahedron just has these tetrahedrons on the top of an octahedron, 8 of them. And when we take those away, what we get left with is the octahedron. So there we go. We have there all 5 Platonic solids, all done with just the circle pattern, and no lines were necessary to do it at all. Now we're going to have a little bit of more fun with the diagram and show how other forms that are unique challenge to draw in sacred geometry are easily found within this. Here I'm drawing the icosahedron, and this is the dual form of the rhombic tricontahedron. It's got 30 vertices, 32 faces, and this 20 pentagon shaped faces. And I mean, excuse me, the 20 triangles, equilateral triangles, and the 12 pentagon faces. And you get this form by either truncating the icosahedron or the dodecahedron at the midpoint. And when you do, you get left with this form. This is a great form, though, because what it is really the vertices of this, much like the cube. Remember, the cube, the dodecahedron is made up of the vertices of 5 cubes. Well, the vertices of this form are made up of 5 octahedra that are creating the vertices of this one. So I left that little octahedra down in the middle, octahedron in the middle, and I'm going to draw on an octahedra that's showing you, octahedron, where the vertices of are within the icosahedron of the same orientation of one of those octahedra, same one to the small one. So remember, there are 5 of the large ones. Could technically do this again at this smaller scale. It's just hard to pick up the rest of the points without more circles, and probably the addition of lines at that point. But this was quite a cool little discovery, is that at that scale, we do have the octahedra within an octahedra. And basically the hexagon there is fitting right inside the equilateral triangle of the larger hexagon. So it's kind of neat to just see how a lot of these forms relate and interconnect. At the scaling we're working at right now, these two are not with the phi ratio edge length proportion, but you can draw a lot of these things, especially once we do use lines, to get everything scaled into kind of an infinite compression type of model. So let's just clear up the octahedron here that are in the diagram. I'm just going to clean up some of the dots. And we're going to switch over to the presentation in just a second. I just want to revisit just the circle pattern that we started with. And that was the only 2 additional circles that I removed early on, and everything else has been just with circles, no lines. And all by the help of the 1.5-inch radius of the 2 large circles, creating the ability to add the root 5 circle, and the rest was done just complete with a compass to fully populate this, and the divine proportion just showed up magically within every flower of life cell, circle cell in there. So let's go and switch over to the presentation. I hope you enjoyed kind of doing a walkthrough of the forms on the iPad there, because I typically don't do that in my presentations, but it is nice to just show the forms constructed like that. So I hope that was useful. The forms that we looked at, just to run through them before I switch back over, we started off with a big tricontahedron, right? And then that one had the 2 hexagon shapes. Then we had the compound of both of those with the line showing up on it, which was this one here. And then we had these icosahedron and dodecahedron with 5 ratio edges, which are creating the golden rhombus. And then we worked our way through this to identify the 1 cube that was in here that went along the face. So if we put this one in here, it would create one of the edges along the length of the pentagram face star that would be in here. And then we got further into our cube and saw that this little star tetrahedron, or the star tetrahedron faces, were making up our cube. So that's the same size as that. So we had the star tetrahedron, and that's just one of the tetrahedrons by itself. And when we take off all those, then we finally worked our way back down to this octahedron, and then we built our way out to show the icosahedron. So, that was all done just with the circle pattern. And let's just hop over to the slide share real quick. And I want to talk just a little bit more about the circles and show you some of the other drawings I did in preparation of this. And so here's the diameter of the circles one more time. The 3-inch diameter circles, two of those. Well, we started off, of course, with the 1-inch units to give us the flower of life. And that gave us the ability to draw the 3-inch circle. And then that, of course, fits around the whole pattern itself. So remember, the whole pattern, without the large circle that I did here, is 66 circles. And then though that was made, that gave us the purple root 5 circle. And that intersected this circle at the top here that allows us to draw our first square root of 2 circle. And once we've done that 6 times, then we start to introduce the 1 divided by phi, 0.618 phi ratio circle inside the black circle. And then we went 1 circle smaller in phi ratio to the blue. And it just all happens like that. It's a very interesting drawing that you can do it that way. And there's a few other things I wanted to show that, we can draw just one of those cubes of the larger dodecahedron, and we can draw a smaller icosahedron within that. And now this edge length of the icosahedron and this one and that one, they're in contact with the face of the cube. 6 edges of that icosahedron will be touching the 6 faces of the cube. And I put a smaller dodecahedron in here that if it were stellated would be inside that icosahedron. There's just the rhombic tricontahedron just by itself with no crisscrossing of lines. This is such a key form. You can never draw it in the flower of life without phi ratio having to show up somewhere, because we're dealing with the golden rhombus. So you could see that if we did just follow the normal flower of life pattern, we would only be able to center our lines pretty much on the vertices, or we could find additional lines. We'd have to add more and more lines to get the right proportion. It might be possible, but the circles seem to do the job just fine. So once they're in there, we can only, we can just go a phi proportion distance here to create this other hexagon within. Now, here's a nice star-looking pattern. It's not a star tetrahedron. It's actually the small stellated dodecahedron, which is actually the vertices of the 12 vertices on this, which would make an icosahedron, and that easily shows up in the drawing too. I have a whole other drawing lesson on this on the Kepler-Poinsot polyhedra. It shows this view from a variety of different views, this form, in addition to the great stellated dodecahedron, which is this one here. And these are, essentially pentagram stars that are being treated like a polygon, and they're interlocking in a way to create a solid, a regular solid. They're like the Platonic solids in that they're the 4 regular polyhedra that were discovered by Kepler and Poinsot. So they are, just as unique and interesting and special as the 5 Platonic solids. And this one creates the 20 vertices of the dodecahedron. And it is a stellated dodecahedron. Most people call it a stellation of an icosahedron because down in here, these 20 points are coming off an icosahedron, but that's not really the way that it's classified. So I wanted to show that the pattern could also be done like this, and it's another unique and cool way to do it, where we start off with our octahedron in the 0.618 phi ratio circle in the middle, and you can extend the octahedron edges in phi ratio. So this would be 1 to 0.618 edge of the octahedron, and when you extend those lines out, we do have the cross point of circles that give us the intersection points to make the larger hexagon of our icosahedron, and of course the triangles. And when we connect all the dots, we get another lovely icosahedron. Again, and this one, it has to be tilted because the octahedron is now the hexagon orientation. It's going to be one or the other in these diagrams. I'll show you a side by side in a moment. But we can also then nest all the Platonic solids in here with just the addition of 6 more circles, which once again, we don't need lines to get those. They're in the proportion of the phi ratio circles, so you can easily use your compass to just add these 6 little circles in there. So if we add those 6 more little circles, we actually have the 72 circles. And just as a note, I've added some other larger circles to just continue on to kind of give it a fruit of life expression. But for this drawing, it's not really needed for the remainder of for the forms themselves on the inside. So, one must be tilted in these views. And I think that's one thing that in Metatron's cube, it's not showing that how these forms are holistic and interrelating with one another, because it tries to orient the hexagon and the hexagon being both the same orientation as the octahedron, as well as the icosahedron, and they don't really jive together that way. I mean, we could do it now that we've drawn the forms properly, but you will not draw a straight edge. That would be an octahedron here, a big octahedron. And unfortunately, that's what's happening in Metatron's cube. And it's very popular, but I think it's going to be worked on being directed to this version in the future. And like I was saying, if we have the octahedron facing this way, with an equilateral triangle here, then all the structural geometry that's associated with this, because there's the cube as well, once that's in there, the dodecahedron that's built off of the cube is going to turn everything, tilt everything to the side, because that dodecahedron pentagon face, which is in red, has to adjust itself. And that means the icosahedron that is around that dodecahedron, because remember, that could be a stellated dodecahedron or pentagram faces with inside the icosahedron, that's going to orient everything to the side. So, both methods are there, which is very, very cool. It's a unique style drawing that you get both like that easily in the diagram. And it's not too hard to draw this one, actually. And I prefer this one. It seems to be easier. And I like that the 5 cubes are just straight on, and we're not giving predominance to one cube of 5 in it. And then all the 5 forms have to kind of contort to the cube rather than the one of the 5 cubes, all 5 cubes basically nesting in the in the rhombic triconahedron. So I think this is also an important shift in the drawings. So this is what would happen to just one cube that would be in a dodecahedron. It looks like it's tilted, but remember, it's part of 5, so it's really just one of a group. So to draw 1 is kind of leaving the rest of the 4 out of the picture. But that's what we've been doing for a long time, and also why these forms have avoided us in this view for a long time, because it is tricky to try and draw the rest of the 5 cubes when you have one being the central hexagon. But definitely possible, but not possible either of the drawings without the golden ratio somewhere being involved in this, because these pentagram faces or pentagon faces that we see of both the icosahedron and dodecahedron, they're going to maintain their golden ratio proportions in edge length. And if we drew pentagram stars within them, even though they're not flat to us, they're going to maintain 5 golden proportions even at the tilted angles that we see here. So that's just hugely significant, and allows for the ability to expand our capacity to work with the golden ratio forms and open up a whole plethora of different forms that are just kind of buried away in the diagrams of Coxeter's work or Wikipedia pages, all those other forms that may be seeming distally out of our consciousness, like rhombic triconahedron for even that instance. They all come to life and become part of the pattern language of sacred geometry that you get to build a relationship and interact with. That's deeply evolutionary flow for, your stream of consciousness to engage with the different forms other than the cube, octahedron and tetrahedron. Because that's really what we've got as our predominant model. And of course, the vector equilibrium in here, and this is really giving us our frozen static state of, geometry. And of course, much of crystalline structure, except for the quasi-crystals, which had quite a problem getting into the mindset of scientists that work with crystals and minerals to accept the quasi-crystals that have phi ratio and goal and proportion in it, because everything was of a cubic nature. And many models and structures of the universe working with the structure of the vacuum in a perfect equilibrium state, well, there is disequilibrium in that, and that allows for change in evolution and growth. And it's not too much for phi ratio to be just off of, let's say, 0.5, the center, to be a little bit under or a little bit over that, to kind of create a lot more. I mean, that's where I think life exists, within those ranges. So this is Metatron's cube. It's got 39 lines, and you don't have to draw all 61 circles. You could shortcut it to the 13 circles of fruit of life. But for the most part, you draw out the 61 circles would be the whole thing. And then we draw our 39 lines. And you could see that there's not going to be any bend to these lines. And now we have definitely a large cube, and we have that smaller cube with inside it and a smaller octahedron within it, and we can continue doing that. So there's really nothing wrong with just drawing cubes, octahedron, tetrahedrons, and all that. It's very, very fun to do. Well, that's not all of sacred geometry, and it's a little bit of a shame that it's claiming to host the rest of sacred geometry, not the rest, but a lot of it, meaning the full models of all the Platonic solids. So with no phi proportion showing up in here, of course you could get phi proportion in there, but to have the whole structure kind of work with the forms, the golden ratio circles that I'm showing here, one of the easiest way, specifically even just with the root 2 circles, will do to get the phi ratio in there in the first place. So you don't even have to draw a golden ratio circle. You can do a lot just with root 2, but hey, golden ratio is there, it's invisible. It's just in the pattern invisibly there. But if you just put your compass to it and spin out circles, you'll get this pattern. But really, root 5 was the essential key ingredient of this. So we did have to adjust our compass, but that's what our compasses are for, is not to get just fixed and locked into one dimension of one diameter. And that is a good way to phrase it, because this is just one hexagonal flat plane, where this type of drawing, when we get these golden ratio circles going, and you can really get them imploding, because each of these circles are going to go with what Dan Winter calls the kind of infinite non-destructive compression of charge through each one of these, then we're really talking about a model that has a lot of dimensionality, and the forms are going to show up at different stages of compression. So whole icosahedra, dodecahedron can be little tiny ones to huge ones here. And it's really just a lot different than smaller and larger octahedron and cube, kind of more like, I don't know, Minecraft or something within just one locked system. Okay, that's this is 66 circles. Just to reiterate, the amazing thing about this for me, and the challenge that was set forth, was to construct the whole pattern with no lines until we started drawing the forms. This was how I did it. Maybe there's another cool way to do it. But this is only one perspective, just from the hexagonal view, and all the other views, pentagon view, of course, and the square view, as I call it, which lead to some other very unique views of drawing these forms. It's just one view of the whole thing and not the whole kabang. So it's just still one perspective of the whole. So it does contain all the Platonic solids and much, much more, which you can check out in some of my other videos, like Metatron's tetraplex. I am using circle lines. It does make working with the pattern a lot easier, and definitely some shortcuts besides building it out all this way. But I guess basically what I'm saying here is that the lines of this pattern over here, Metatron's cube, are really lines of the forms themselves anyway. So what we're doing with the circle pattern is drawing in the lines of the forms, and they're already tetrahedron, octahedron, and different scales. So really, this is just a circle pattern that can be used to get us to just when we start drawing lines, it becomes these golden proportioned forms. So we just had to find an augmented system to the traditional flower of life, fruit of life design, that when we start drawing those lines, they have meaning right away. And they're not just setup lines for something else. The setup lines in here to draw the phi ratio forms of Metatron's cube, they really don't do anything. And the only reason you need to do the setup lines is to try and create that dodecahedron. But it's not the same dodecahedron that we find in this pattern over here. And it kind of locks us in a geometry that's kind of a dead end, in meaning that it's not a true stellation of that. There's no icosahedron. There's nothing with no phi ratio forms. So thank you for sharing my 100th celebration video, and really following this trail out for myself, because when I first discovered that the Metatron's cube did not contain the Platonic solids, it really did put me on a quest to come up with more and more unique ways to draw the Platonic solids and explore the other views and kind of bringing them all together and see what I was learning from one and creating some very cool forms along the way. And this was kind of my ultimate challenge, was to do the whole pattern without any lines, which hopefully you enjoyed seeing today. So thanks for joining me, and please subscribe to the channel if you really love the content. I'm going to be slowing down with some of the video distribution. I think probably will be doing more pretty soon. Work on, redeveloping the style of new geometry and giving it a new direction of where it will be headed in the future. But I do host online apprenticeships, so you can join me for that, which will be ongoing. I'm in the middle of one now, or just started one. And the Patreon that I have set up walks you through how to draw these 5 Platonic solids with a much more simplified method than I showed today, with the golden seed of life. And that's a whole volume 1 is already done with 12 videos associated with the 54 pages of writing and instructional diagrams that go one for one, so you can work on that. And it's $9.99 over at Patreon. So if you're interested in learning to draw this and learning about the golden ratio circles and working them within your own drawings, go check that out. And that's being rehashed into a book model and other online platforms. So there will be more opportunities to learn new geometry very soon. Check out New Geometers Facebook group, and there's about 2,100 geometers over there that are sharing posts and interesting topics. So there are certainly abundant opportunities to engage with the material that's been presented, along with the 100 videos that are on here. So thank you, and I'll see you next time. Peace and love.